Hey everyone! Welcome back to our channel, where we dive deep into the fascinating world of technology and artificial intelligence. If you're new here, don't forget to hit that subscribe button and ring the bell so you never miss an update. Today, we're going to unravel an essential concept that powers many of the AI models we see today: backpropagation in neural networks. So, let's get started. Before we jump into the nitty-gritty, let me ask you a question. Have you ever wondered how machines learn from their mistakes? Well, that's exactly what backpropagation helps achieve in neural networks. But how does it work? Let's break it down. To understand backpropagation, we need to start with the basics of neural networks. Think of a neural network as a complex web of interconnected nodes, or neurons, that mimic the way our brains work. These neurons are organized in layers: an input layer, one or more hidden layers, and an output layer. When we feed data into a neural network, like images, texts, or any other information, the input layer processes this data. Each neuron takes in the inputs, applies a weight, sums them up, and passes this information through an activation function, which determines whether the neuron fires or not. This process continues through the hidden layers until we reach the output layer, which gives us the network's prediction. But here's the catch: when we first train our neural network, its predictions are often incorrect. So, how do we improve its accuracy? That's where backpropagation comes into play. Let's consider an example. Suppose we have a neural network designed to identify whether an image is of a cat or a dog. Initially, the network sees an image of a dog and predicts it as a cat. This prediction is incorrect, and we need to adjust the network to learn from this mistake. Backpropagation helps us do just that. After the network makes a prediction, we compare it to the actual label. We calculate the error, which is the difference between the predicted output and the actual output. This error is crucial because it tells us how far off the network is from the correct answer. Now, let's break this down further. The process of backpropagation consists of two main phases: the forward pass and the backward pass. 1. Forward pass. As we discussed, this is where input data is fed into the network and predictions are made. 2. Backward pass. Now, here's the magic. During the backward pass, we start from the output layer and work our way back to the input layer. We compute the gradient of the loss function concerning each weight in the network. This tells us how much each weight contributed to the error. To visualize this, imagine you're hiking up a hill and want to get back to the valley. You'd look for the steepest slope to guide you downwards. In backpropagation, we're essentially doing the same thing. We adjust the weights in the opposite direction of the gradient to minimize the error, using an algorithm called gradient descent. To put this into perspective with some data, let's say we have a neural network with 3 layers and 5 neurons in each layer. During backpropagation, if we have 100 training examples, we'll calculate the error for each example and adjust weights accordingly. With each iteration, the network learns, and its predictions improve. In fact, studies have shown that with enough training data and iterations, neural networks can achieve accuracy rates exceeding 95% in tasks like image classification. This is why backpropagation is a cornerstone of deep learning. Think about self-driving cars. They use neural networks to understand their environment. When a car misidentifies a stop sign as a yield sign, backpropagation allows the neural network to learn from this mistake, improving its performance over time, making the car safer and more reliable. So, to wrap it all up, backpropagation is a crucial process that enables neural networks to learn from their mistakes by adjusting the weights based on the error of their predictions. It's like giving the network a map to find its way back to the right answer. If you found this video helpful and want to learn more about the incredible world of AI and machine learning, give us a thumbs up and let us know in the comments what topics you'd like us to cover next. Don't forget to subscribe for more educational content. Thanks for watching, and see you in the next video.